Hey, today we're going to talk about inequality word problems. So in our notes, we're going to be on page 19 and 20. And as I'm going there, we just need to remember with these word problems, we just have to figure out what we don't know, which will be our variable. And then the hardest task will be how to write it algebraically, and then just practicing solving and understanding what the solution means. Some of these will be easier and some of them will be a little bit harder. So if you are still stuck on a couple questions, like problems like how did I get that answer, we'll have time tomorrow to also tackle some of these problems, because tomorrow we're just going to review for our test. So this first example, and I apologize, these are just screenshots, so the numbers don't really correlate. But for this one, what is the smallest value of x that is not a solution to 4x minus 26 is less than 6? So we need to figure out which would be the smallest number that would not be an answer. So first, we should probably just solve this. So we're going to add 26. We're going to divide by 4. And 30 divided by 4 is 7.5. Okay. So x is any number that is less than 7.5. So the question is, what is the smallest value of x that is not a solution to this inequality? So if we just think about what we're talking about, x is anything that is smaller than 7.5, but is not actually equal to 7.5. So the smallest number that would not be a solution would actually be 7.5. This is the smallest number that's not a solution. So the next problem, Rajesh has $37.25 in his wallet. He would like to purchase a movie ticket and some candy. The ticket costs $7.25, and each box of candy costs $3.75. He claims he can buy 5 boxes. Do you agree or disagree? Write and solve an inequality to explain your reasoning. Okay, so we first need to figure out what we're talking about. Like, what is it that we don't know? And he knows he wants to buy 1 ticket and he wants to buy some candy, but we don't know the number of boxes of candy. Okay. So we know that our total is $37.25. So I'm going to put this over here. Okay. And how he's getting to $37.25 is he buys a movie ticket, which is $7.25. And additionally, he is buying candy for $3.75 each. So for each box of candy, $3.75. We don't know how many boxes of candy, so we're going to put the variable on that one. Okay, now this problem is not actually an equation. We're not going to put an equal sign. We're actually going to put an inequality sign. And that is because he has $37.25. They're not saying that he spends this entire amount. He could spend less. So when we figure out our inequality symbol, we need to just basically compare our total. Is our total the biggest or the smallest thing? And this is the most money that he has. So I'm going to show this is the largest that it can be. He could also spend his entire amount, which would be okay. So the inequality that we can write is 725 plus 375x is less than or equal to 37.25. Again, this amount needs to be smaller or equal to the total that he has in his wallet. All right, so now we are going to solve it. So we're going to take the movie ticket out of the problem. So then we would divide by each box of candy. Okay. And 330 divided by 375 is 8. Let me check real quick. Okay, 8. So x is less than or equal to 8, which means he can buy up to 8 boxes of candy. So he claims that he can buy 5 boxes. Do we agree or disagree? So he can buy up to 8, so we agree with that claim. Okay. All right, for this next problem, Mason's pet leopard gecko must be kept in a cage with a temperature of at least 82 degrees. Using the inequality below, solve for C to determine the safe range of temperatures for his gecko in degrees Celsius. Okay, so it says 9/5 C plus 32 is greater than or equal to 82. Again, it says at least 82. So this amount needs to be at least, so bigger or equal to 82 degrees. So we are just going to solve for the C or Celsius to figure out what temperature that would have to be. So we're going to take a subtract 32. That would be 50. All right, from here, you guys can just divide by 9/5, or you can multiply by the reciprocal. They both mean the same thing. Okay, so 50 divided by 9/5, I get 27.7 repeating. Okay. Or if you guys like fractions, this would be greater than or equal to 27 7/8. Okay. So it says, what would be a safe range for his leopard gecko? Anything greater than or equal to 27.7 degrees Celsius. Okay, next problem. Glenn has $1,250 in his savings account. In order to avoid a bank fee, he must keep a minimum of $150 in his account. His cell phone costs $35 per month. Use an inequality to determine how many months Glenn can pay for his cell phone before he would incur fees. So the first thing is, what is the question? Well, it says how many months can he pay? So X would be the number of months. Okay. All right, so there's a couple ways we could write this problem. It's basically how you interpret the total to be, okay? When I read this problem, this looks like the starting amount to me, so this will be one way to do it. So $1,250, I start with $1,250, and he wants to avoid bank fees, so he must keep a minimum of $150. So to me, this would be the answer. So I'm gonna put $150 over on this side. Okay. And what is happening is from this $1,250, he's spending $35 a month for his cell phone. So I'm going to take off $35 every single month. Okay? So we need to have a minimum of this amount. So this needs to be the smallest amount that he has in his bank account or more. Okay, so 150 is the smallest amount, so I'm going to make that the smallest. It could also be 150, but it would probably be cutting close. Okay. Another way you could write this is if you interpret this problem to be 1,250 to be your total, which is fine. Okay. Then you would have your 150 that he wants to keep as his minimum. But additionally, he has to take out the 35x every single month. Okay? Then in this problem, this is the largest that he has because that's all he has in his bank account. And we would see when are these equal, or when is this amount less than. Okay, so both of them will get you guys the same answer. So we can subtract 1,250, get 1,100, negative 1,100. Okay, or you could do it the other way and get 35x, still 1,100. Then we would divide by negative 35. And in this problem, because we're dividing by a negative, we would flip the sign. Okay, so we flip it, less than, and we get a decimal, divided by 35, and we get 31.428, blah, blah, blah. Okay, if we did it the other way, we would divide by 35 as well. We wouldn't flip because we divided by a positive number, but we still get the same exact answer. So with word problems, it's kind of however you interpret it, and whatever makes more sense to you. Okay, so it says, how many months can Glenn pay for his cell phone before he would incur fees? So 31.48 would be the maximum number of months. So he could pay for up to, we'll say just 31 months, just to make sure it makes sense. Because if he went to 32 months, he would overdraft. So up to 31 months before he would incur any fees or have any fees. All right. This problem is probably my least favorite because it took me a while to understand it, but that's okay. Rodney is flying on an airplane to Puerto Rico. His suitcase and his contents inside must weigh less than 50 pounds. His suitcase weighs 4 pounds and the contents he wants to pack weighs 49 pounds. If each of his shirts weigh 0.75 pounds, write an inequality to represent the number of shirts he needs to remove to meet the flight requirements. So right now he needs to have something that weighs less than 50 pounds. So I'm just going to write less than 50 pounds. That's what it needs to be. Okay. Right now he has his suitcase that weighs 4 pounds and he has his contents inside that weigh 49, or a total of 53. Okay. So you could write 53 or you could write just 49 and 44 together. Okay. Obviously that is too much. And so we would have to take things out of his suitcase. So we are going to remove some shirts, and each of his shirts, so X is the number of shirts, each shirt is 0.75 pounds. So we are going to subtract out at 0.75 for every single shirt that we want to remove. Okay, so I'm going to put these together and get 53 total pounds, but that's too much. So I'm going to take out some shirts that weigh 0.75 pounds each, and that needs to be less than 50. So we are going to subtract 53. And again, I can just use common sense and know that I'm 3 pounds over right now. Okay, then I would divide out what each shirt weighs because I have 3 additional pounds. My dog's going to go outside. Hold on one sec. All right, and because I divided by a negative in this representation, I would have to flip the sign. Okay, and so 3 divided by 0.75 would be 4. So X is greater than 4. Okay, so, and again, it needs to be less than 50 pounds. That's why I didn't use or equal to. So we need to determine how many shirts he needs to remove. He needs to remove at least 5 shirts, because then it would be less than 50 total. All right, let me go real quick. Oh, be free. Okay, sorry about that. All right. The next one is Celine and Bennett are solving an inequality below. Celine says that you will need to flip the inequality sign, while Bennett claims you will not need to flip it. Who is correct, and explain your reasoning? Okay, so really we're just trying to make sure we understand we only flip a sign when we multiply or divide by a negative. So I'm just going to go ahead and distribute. Okay, I'm going to combine like terms. And then I'm going to divide. I'm going to divide by a positive 2. So it looks alike. Bennett is correct. And because we divided by a positive 2, not a negative. All right, so what I'm going to have you guys do is I'm going to have you guys try 8 and 9 and bring that back to the table in class tomorrow. 8, 9, and 10, excuse me. And then we are just going to do this last problem with the dog food problem. So after we do the dog food problem, go ahead and try these 3. And then there is a Savas. There's 6 questions that you guys are going to try. Okay. So Enrique plans a diet for his dog, River. River consumes between 510 and 540 calories per day. If River eats a serving of dog food each day, how many treats can she have? Okay, so when I look at these, this is 2 numbers that she needs to stay in between. So when I think about things that are in between, I think of a compound inequality. I think of 2 situations. Okay, so the question is how many treats can River have? Okay, so the smallest amount that she can have is 510. Okay. And the largest amount of calories she can have is 540. So we need to stay in between these 2 numbers. Okay. So how she's getting all of her calories is she says she's having a full serving of dog food. So she's going to have 320 calories no matter what. And then she's additionally going to get some treats. And each treat is 15 calories. But I don't know how many treats we can give her quite yet to stay within the threshold. So we'll put X. So this is the inequality that we can represent. 510 is less than or equal to 320 plus 15X, which is less than or equal to 540. Okay, so now we just need to solve this inequality. So I'm going to take out the serving of dog food first because she has to have that. So we're going to subtract 320. And that would be 190. And 220. And then we're going to divide by how many calories a treat is. And we get something like 12.6666 and 14.66666. Yep. Okay. So this is the solution to our inequality. Okay. And then we just have to make sense of it. With real world problems, we should be able to hopefully make more sense than decimals because we're talking about treats. We can't, I don't know how many people cut up their treats into thirds, but this just means that X needs to be greater than or equal to 12 and 2/3 or 12.66666. And at the same time, X needs to be less than 14 and 2/3. So if I were just to interpret that, that means that River can have between 13, because that would be the next whole number up, and 14, because 15 would be too much. All right, so tomorrow I want us to talk about these 3 problems. So go ahead and try those, and then go ahead and also try the Savas problems as well. You will have more time to work on it tomorrow. We're just going to review. So if there is one that you are struggling with, just hold off and we can do it in class tomorrow. All right, I'll see you guys.